All right, today we are looking at area of squares using the Pythagorean theorem. So the Pythagorean theorem basically says that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. So see here, that's the hypotenuse. It's right across from the right angle. That is the hypotenuse, and then A and B represent the other two sides. But what we could see in this diagram is how the area of a square drawn on the hypotenuse is equal to the sum of the area of the squares drawn on the other two sides. So this actually is a square here. It's a square which is 5 by 5. This square here is a 3 by 3 square, and this square here is a 4 by 4 square. All right, so the area of a square, this area here of a square drawn on the hypotenuse, is equal to the sum of the areas of the squares drawn on the other two sides. And that gives us our Pythagorean theorem, which is c squared equals a squared plus b squared. So like I said, our c here in our triangle is represented by the hypotenuse, which will be 5 squared, shown here. Our a is 3 squared, like so, and our b is represented by 4 squared. All right, so 5 squared, which is 5 times 5, gives us 25. 3 squared is equal to 9, and 4 squared is equal to 16. So when we add 9 plus 16 together, we have 25 units squared, and the left side is also 25 units squared. So therefore, this proves that this triangle is a right-angled triangle. Okay, so we're going to look at this triangle next, and we have to be able to prove if this is a right triangle or not. So we're going to use our Pythagorean theorem, which is a squared plus b squared is equal to c squared. So our longest side here, the 12, that is our c, representing the hypotenuse. This side here is our a, and this side is the b. All right, so that means 8 squared plus 9 squared has to equal to 12 squared. All right, so we got 64 plus 81 is equal to 144. 64 plus 81, that gives me 145. So 145 is not equal to 144. So therefore, we can say that the left side does not equal the right side. And we can say, therefore, it is not a right triangle. All right, let's try this triangle here. We have to answer this question: is this a right triangle? Okay, so we'll call the longest side is the hypotenuse. This is the A and this is the B. Hypotenuse is always represented by C. So in our formula then, A squared plus B squared has to equal to C squared. So 10 squared plus 5 squared has to equal to 11 squared for this to be a right triangle. And this gives us 100 plus 25 has to equal to 121. And this is not true. 100 plus 25 gives us 125. It is not equal to 121. All right, so therefore, it is not a right triangle. All right, so after that, we get into Pythagorean triplets or Pythagorean triads. So, Pythagorean triplets or triads. And basically, you're given 3 numbers to determine whether or not they satisfy the Pythagorean theorem. to be a right triangle. So for example, if you're given a set of numbers 3, 4, and 5, are these set of numbers a triplet, triad, a Pythagorean triplet or triad? All right, so this largest number is represented by C for hypotenuse, and then A and B for the other two. So A squared plus B squared has to equal to C squared. So 3 squared plus 4 squared has to equal to 5 squared. So 9 plus 16 has to equal to 25, and that is true. All right, so therefore 3, 4, and 5 is a Pythagorean triplet or a Pythagorean triad. All right, let's say we were looking at the numbers 5, 6, and 7. Again, the largest number is represented as the C, the hypotenuse. 5 and 6 would be the A and B. All right, so A squared plus B squared equals C squared. So 5 squared plus 6 squared has to equal to 7 squared. So that gives me 25 plus 36 has to equal to 49. 25 plus 36 is equal to 61. So 61 does not equal to 49. All right, so therefore the numbers 5, 6, and 7 are not a Pythagorean triplet. So therefore 5, 6, 7 are not Pythagorean triplets. Or 5, 6, and 7 are not a Pythagorean triplet.